Good afternoon. I hope that you have heard something about Firebase so far at this Google I/O. Yes? A little bit? Well, if you haven't heard, Firebase is Google's mobile platform that helps you build applications quickly and grow your business. And I lead part of the Firebase engineering team that's at the intersection of Firebase and cloud on the server side. And I'm really excited that on this stage with me is the person who introduced me to Firebase long before Firebase and Google were a thing, and long before I ever worked at Google. Judy.
Hello, my name is Judy Swan, and I currently do advocacy with Tech Workers Coalition in San Francisco. 5 years ago, in fact, just over 5 years ago, we looked it up this morning, it was May 3rd, I had this idea to go to a hackathon, and I wanted to build, the accelerometer was new at the time, and I wanted to build a paintbrush with your phone, and then you'd like wave it around in 3-space, and then look at the thing that you just drew. So Sarah and I went to this hackathon, and it just so happened to be Firebase's first ever public launch. So originally, it was going to be local to a single phone, but with Firebase, we could really easily shove the data onto a web view, and that made our demo much more impactful, and it was super fun. And as a result, Sarah and I are Firebase developers 22 and 23, and it's extra exciting that at the keynote, they said that Firebase now, the community of Firebase developers is now 1 million strong. So I never imagined that I'd be up here. I never imagined that I'd be up here sharing this with you.
So in preparation for this Google I/O, in recognition that Firebase has grown to be many, many things, I thought about what could we put together that could illustrate how we build server applications, client-server applications in this new world. And I thought about who do I know who is really good with development patterns in general, has been developing a really long time. And Jen May we were doing servers, client-server software when we used to call them just virtual machines, before cloud was really a thing. And so I'm really excited to have Jen May here on the stage with me as well.
Yeah, thanks, Sarah. My name is Jen May. I work at Indiegogo, which is a crowdfunding platform and also an early product launchpad. We're based in San Francisco. And we're hiring, so if you're interested, please come and talk to me later. In addition to Indiegogo, I also work with a bunch of nonprofit organizations and activist groups, including Liberating Ourselves Locally, which is a people of color-led makerspace and hackerspace in East Oakland. And I would love it if you want to find out more, you can check out my Twitter feed. There is couple interesting articles on Autostraddle and KQED about us working with the Oakland Community Law Fund to preserve that space for the community. But the reason I mention LOL is because our community is mostly people, not techies, but people who are activists, people who are artists, some of whom have technical backgrounds, but many of whom do not. And because of my involvement in this space, I often get requests from people to write applications for them. A lot of people think that you can just write an app, hand it to someone, and you're good. But as we all know, if it's a network app, you need to have some infrastructure that runs on. And so the East Bay Meditation Center, which is another organization in Oakland, asked for a user registration system for their events. And I ended up building this on the desktop because the idea of writing an application and putting it on the internet would require a whole lot of work that would mean that 90% of the work would be going into something they don't care about, as opposed to user registration, which was the one thing that they do care about. So when my friend Sarah started working with the Firebase team and asked me if I'd be interested in working on a project for Firebase, I thought, this is kind of awesome, because this is a technology which is serverless, and so it should take care of those authentication issues and security issues and deployment issues without having to have a nonprofit like UBMC being responsible for it. which maybe would be really easy.
So in this talk, we're really going to dig into some of the challenges across client and server. And I'm really excited to hear about the work that Jen May was talking about, where this technology enables small organizations to leverage technology in ways that they couldn't before, right? Because they don't have many developers. Their developers might be there intermittently. They don't have an ops team. But what this technology is also really good for, which is the main topic of our talk, is creating an application that is going to scale phenomenally with your business. And these kinds of applications are frequently called serverless applications. And it's not because you're not writing server code. It's because you're not managing servers. But we have some of the same issues that we've always had writing client-server software. And we'll talk to you about how we're dealing with those in a specific application that we developed as an open source team. So you all probably know, if you develop mobile applications, that those applications are running on a wide variety of operating systems, a whole bunch of different devices, different screen sizes, and we have to write code to deal with that. Not only that, but your app is running far, far away. It might have low bandwidth, intermittent connectivity. You have to deal with that. And usually these days, it's a lot easier to avoid crashes, but if your app does crash, your user is very aware that that's going on. Whereas on the server side, we have code that's running in the cloud. And paradoxically, out in the cloud, it's actually very close to us. We can instrument it easily. We can deploy new versions. We can look at our log files. And when it crashes, it's very different behavior. And it might not actually crash because of our bug, right? Your data center might be hit by a tornado and your code ceases to execute randomly in the middle of execution. And we have to write code differently, knowing that that's a possibility. And of course, if those unusual but expected events happen, then you need to do things to make sure that your user actually has a good experience at the other end of the line. So we'll be talking about a few of these challenges and specific solutions, how we often want to keep some of the logic on the server side in order to protect our algorithms and make them run in a resilient way, how to deal with authentication and access control, and how to simplify your UI through real-time data binding. The technologies that we're using are specific Google and Firebase technologies, but I think these applications transcend the specific technologies we're using. The Firebase real-time database, Cloud Functions for Firebase, Cloud Data Store on the server side, and then to connect client and server, we are using Firebase Authentication, and we have clients in web, iOS, and Android. And then incidentally, because it was convenient, we're hosting using Firebase hosting, and we used Firebase Remote Config for a kill switch for making old versions go away when we no longer want to support them. And you can see the code at github.com/allthehubbub. So now I'd like to invite Judy to tell us a little bit about the app, so you have some context for the presentation.
Thank you, Sarah. OK, so before going over common patterns that you can use for a typical application, I'll define what we mean by typical in this context. So here are some characteristics that are common in many apps. Almost everything we're building these days connects to cloud services to store data and shows this data to a user via a client UI. And often you'll have a user profile, perhaps connecting multiple social platforms. But the reason you're doing all of this, and the reason we're all here, is that your application will do something special. It's got to have some kind of secret sauce. And hopefully, you'll be presenting something useful to people. So Hubbub, this app we dreamed up, is an example of an app that uses these patterns. So we'll go through the user interactions first, so you'll have context for the technical patterns we're going to show you in the rest of the talk. So on with the whirlwind tour. First, you log in with GitHub. We automatically create a Hubbub profile for you in the background, invisibly to you, using public information from your GitHub profile. You press the Material Plus button to add events, which brings you to an events list. So here you can pick which events to join, and you go back to your home screen where you've seen the events that you've signed up for. After enough people have joined a particular event, it's up to us as Hubbub admins to assign lunch groups. And we do that via a web interface. So here's our admin console on the web. After you've all signed up for lunch, we'll make group assignments. So we hit the button, secret awesome sauce happens, and when you look at your homepage on your device, you will see that you've been assigned to a group. And since we're using real time, you'll see it immediately. So you're assigned a topic. It's got all of the information about where to go and when. And when you report to the community area to meet fellow lunchers, you'll tap on Find Your Group, which will bring up what we're calling the beacon screen. You'll hold up your phone and find people with the same bub, and that's how you'll match with your groups. So then you don't have to yell or hold up a big sign or ever feel lonely again. So now I'll hand it off to Jenmei, who will dive into how the app is built.
Thank you. So I'm going to talk about what's inside the app. So first, you start with, as Judy said, awesome sauce. Your awesome sauce could be a user interface, or it could be a special algorithm that you want to put in front of your users. But before you can put it in front of your users, you have to build up that extra code that I mentioned before. For example, on the client, you have your API client that needs to talk to the server, get some data back, update the UI state in the client that then gets rendered back into the UI for the user. On the server side, you're going to have, first of all, a server, and you're going to have an API service that responds to those requests from the clients and talks to your business logic, including your secret sauce algorithm, which then may talk to a database or some other services before sending data back that goes back to the client. And that just describes the simple case of a situation where you have an application that you want to be able to make queries of a server. If you also want the information flow to go the other way, for example, with real-time updates, then you need to do a bit more work. And that doesn't even get into all the other things that you have to do, like thinking about scaling, or thinking about server maintenance, like if a network card goes bad and you need to switch out a server, or dealing with multiple clients. So here we're just showing one client, but as we mentioned, we have a web client, an Android client, and an iOS client for the Hubbub project. And of course, we haven't talked about the security issues that you might have as well. So our talk is about using Firebase technologies to make all of this easier. So as you can see, all those parts that you would normally have to build yourself are provided for you by Firebase. On the client side, we're using Firebase, the real-time database, to take care of both the state management and also communication with the server. We are also using the authentication features, as Sarah had mentioned earlier, so that we don't have to write that ourselves. On the server side, everything is in the cloud, no servers. I mean, no servers that we care about, there's totally servers. And our algorithm is running in Firebase Cloud Functions. And it is communicating to the client through the Firebase real-time database. And it is also using Cloud Data Store to store some information. And so putting it all together, we have several different applications, a web app, an iOS app, an Android app. They communicate to the real-time database. This causes Cloud Functions to run, which do things like call the GitHub API and process information, put stuff in the Cloud Data Store, push stuff back into the real-time API, or the real-time database, which then pushes information back to the clients. Additionally, the clients are triggering some Cloud Functions using HTTPS. And the reason that we did that is because it was very straightforward for error handling. We could get an immediate response back from the server once we knew what that was, and we could handle it if something unexpected were to take place. And I want to mention real quick, the reason we're using Cloud Data Store on the back end is because we hope that Hubbub will become a very popular application, as many people do when they make apps. And Cloud Data Store, unlike the real-time database, is horizontally scalable. If you have a query that returns 10 results and your database size is 10 megabytes, that'll take the same amount of time as if your database size were 10 petabytes, which is really amazing. And you don't have to take care of any of that scalability yourself. You don't have to provision servers. It's all handled automatically because it's the cloud. So on to our special sauce. So Firebase makes it really easy for us to focus on our special sauce instead of all that infrastructure that we had mentioned. And there's two parts to our special sauce. One is the profile generation, and the other part is the matching process. So first, profile generation. And this is, as Judy mentioned, where on a device, like let's say an iPhone, you run the app and you're prompted to sign in with GitHub. When you sign in with GitHub, all we get back is an OAuth token. And that's our little Hubbub icon saying, wee, because it's dropping the OAuth token onto the real-time database, and something really exciting is going to happen. At this point, your local state doesn't have any information about the user besides the OAuth token. So if we were to display the profile, it would be empty, which you might do for performance reasons. But in our case, we actually show a loading indicator. And then when the information comes back from the real-time database, we then display the profile. So once the OAuth token ends up in the real-time database, it triggers a cloud function, in this case, one to update the profile. This calls out to GitHub, gets some information, and passes it back to the real-time database in a format that we want for the client application, which can then display it to users. And just a real quick note, the way that we're using the real-time database as our API, we've been very careful to kind of sequester the information that's being used for transport versus data that's being used for other purposes that we might want to use on the back end, for example. And with those bits of data, it's going to be really important for us to make sure that if we make schema changes, that those changes are compatible with various versions of our application, because we can't always guarantee that people update when we think that they're going to. So the next secret sauce is our matching process. And the first part of that actually happens during profile generation. So after sending that information to the real-time database, the cloud function actually does a potentially long-running process of calling into GitHub and getting information about you, like your Strud repositories. Depending on how much information that is, it can take a significant amount of time, and we don't want to do that on a client device because you could lose your network connectivity and also battery use. So we do all that in the cloud, and we process all that information. We put it into Cloud Data Store, again, because it is horizontally scalable, and then that's it. We don't put anything into the real-time database because the user doesn't need to know about it. Next, after a whole bunch of people have done that, we have a lot of data in the database. And we, at one point in time before the event, we close reservations so that we don't end up with anybody in a topic by themselves. We want everyone to be able to talk to people who have common interests. And we would create the groups and the topics, and then we announce the groups, and then you can have them on your beacon screen so you can find other hubbubs. Now, I want to take a moment to talk about Cloud Function triggers, which is what we're using to make all this magic happen. As I mentioned before, we are using real-time database writes, and we are using HTTPS. There are also some other triggers, which I'll mention in a little bit. But first, I want to show you about the entry point to Cloud Functions. So Cloud Functions is the functions directory in our web app repo, and index.js is the entry point. And for Firebase Cloud Functions, as opposed to regular Cloud Functions, you don't have to worry about routing for your HTTPS functions. I'm going to show you that soon. But you do need to set up your admin SDK so you have access to the database. the admin SDK differs from the client SDK, which we're using in the client app, because it has privileged access. The client SDK, you only have access to what that logged in user has access to, which Sarah will talk about later, about how we've narrowed that down to a small set of data. But the admin SDK allows us to access anything. And you can only initialize the admin SDK once. So we actually pass our initialized admin SDK instance to these other classes that we have put into other files, because we want to develop our code modularly. And so we have a very small index.js with most of our code extracted to other files. So here's an example of the update profile function. You can see in the slide that we are listening for a change to the GitHub token for a given user ID, which is in braces because we care about that and we want to use it in our cloud function in the accounts collection. When a change happens, which could be the creation of a GitHub token, the deletion of a GitHub token, or a change to the GitHub token, then our cloud function gets triggered, and we're passed an event. And this event includes a user ID, which we can use to query to get the user's information from the real-time database and make our connections to GitHub, and so on. We also have some functions triggered by HTTPS calls. So here's an example of that. This is our time slots, where, as I mentioned before, you don't need to declare a route. It's done for you automatically based on the function name that you are exporting. And this is the difference between Firebase Cloud Functions and regular Cloud Functions. But you still get your request and response objects, similar to what you would use for Express. And there are a few other triggers as well. For example, you can have an authentication trigger. When you authenticate and create an account, that can trigger a cloud function as well. There are analytics events that you can listen to. So if something happens, you can trigger a cloud function to take care of that. And cloud storage, which is an example of which would be if a file gets uploaded. And PubSub. And PubSub is very notable because many services that Google has support PubSub. So for example, Gmail has some events that you could subscribe to, and you could take your cloud functions could be triggered based on those events. And for testing, when you're in development, you can also use the command line interface. And with that, I'm going to pass it back to Sarah to talk about web safety.
So we're developing software for people. And we want to make sure that we keep those people safe, and we keep their data private when it needs to be private. And so I'm going to talk a little bit about authentication, and then spend a little more time talking about how we authorize clients to access different parts of the database using security rules. So first, I'm just going to give a quick overview of OAuth, which we're using in this application to identify the user and also to make back-end calls with, to the GitHub API. So in this case, we have our user, Hubbub Ducky, who logs in to the Hubbub app. The Hubbub app redirects or shows a web view of the GitHub authentication screen. So when people are using OAuth, they're entering their credentials to their OAuth provider. Your app, it doesn't get the username and password. And so that's a key security measure so that the user could always revoke that privilege. So then we are then allowing the user to access our app. So the revocation, it's important to note, is really about our access to that data. So, but then you can also use OAuth simply to identify the user. And then under the hood here, we're using Firebase authentication. So what that does is it manages a lot of these details for you and also allows you to have an identity and an authentication system that could support federated identities. So we could add Twitter or Facebook to this and allow people to log in with multiple identities, and that would be managed by Firebase authentication. So right now, it's a fairly simple system, but knowing a little bit of what's going on under the hood kind of helps us think about how to develop this app. So knowing that the client needs to present the OAuth provider login screen, then helps you remember that the token for that OAuth provider, the GitHub token in our case, is only available on the client. And also, if it were to expire, the client really needs to control the reauthentication. So what we do in that case is we save that GitHub token in the real-time database, which makes it available, as Jen May pointed out, to the server side for accessing the GitHub API. And then if there's to be an error, if that token expires, we set the real-time database to null for that value. That automatically syncs to the client, and then the client can cause the user to log in. So this whole authentication piece is, of course, important when we want to make sure that a specific user is accessing their data and allowing reads and writes according to user information. So when we're developing client-server software, as we are with mobile applications, it's important to remember that even though we might be doing client-side validation, which is a good user experience, all the server is getting is ones and zeros. It doesn't really know that our code is on the other side. So we always need to make sure that from a security perspective, things are locked down on the server side. And with Firebase, we can do that with security rules. So here's a quick overview of the data model of our application. We're going to start with accounts and profiles, which is how we model the user data. So under accounts, for example, is the GitHub token, which is something that's private to the individual user. In profile, those are things that are shared with other people in the community. In our case, it's just public data. So that the way we've locked this down is that we've grouped under accounts, we have user nodes are identified by their UID. And then this expression shows that if we have a matching UID for this node, well, then the request needs to be authenticated, and that user ID needs to match. Whereas profiles are readable by anyone. That's, of course, a business choice. We decided profiles can be used by anybody. A common thing to do is to say, well, we want people to log in to use our app, therefore profiles will require authentication, and that can be expressed with whether auth is null. So our app evolved, and it turns out that we wanted to do some additional things which are available to the client, like whether they're an admin, but you don't want the client to be able to say, yes, I'm an admin, I'm just going to independently decide that and set that to be true. So we modified our server rules so that the client can read anything, but then we whitelist specific fields that have higher privilege. So the client writes the GitHub token, but everything else is read-only. And so this is generally a good pattern. Those of you who do security stuff know that you want to give the most locked down privileges by default, and then select higher access for specific things. So then we have this other set of data that is used by the client and server to do the business of the app. So events are written by, the design was they'd be written by the admin tool. In reality, they're written by a script. So right now, they're just readable by everyone. By default, as Jen May mentioned, they are, the admin SDK can access anything, and so that they can be written from the back end. Requests, these are just a bookkeeping done by the server side. The request to join an event is done by an HTTP trigger. That cloud function stores some information here. Later, another cloud function pulls together the request to assign people to groups. So that doesn't need any rules because by default, the client doesn't have access to anything. For the assignments, this is the grouping. This is a little fancier. We have events, and under those we have topics that are grouped by ID, and under that we have lists of members. So what we decided to do is make it so that you can see any member of your group. And on iOS, we actually designed a screen, which you saw earlier, which shows you the other people in your group. And that's generally a good idea, that you want your privacy model to be transparent in your interface. If the user's data can be seen by other people, it's nice to show that so that they can reason about the privacy of their experience. The way that we express this in security rules is that we can write a slightly more complex expression here that says that, okay, if the members has any child that matches this authenticated user, well, then they can read that whole node. And so you can see how these concise expressions mean that our whole rules take place in about a page, and it can be very easy to audit that our privacy settings are what we want them to be. So use Firebase rules to keep your community safe using this simple declarative syntax. And I want to hand this back to Judy to talk about real time.
OK. So now that we've heard about secret sauce in Cloud Functions and keeping bubs safe with security rules, it's time to get into some client code. So let's look at one tiny part of the app, the profile view, and I'll show you our implementations across 3 client platforms, iOS, Android, and web. So keeping up with the theme of simplifying development, Firebase Real-Time Database has many SDKs, so you can code all the things. Data binding is a user interface pattern to deal with data that changes. Stuff changing in one place means it also changes in the other place, and it's magical. Data flows both this way and that way. So in our app, we've got a client talking to a real-time database, and back again. We've also got Cloud Functions and our admin app passing data back and forth. So for this profile example, we're just looking at data going from the database to the client. So the data is only going in one way. So in these next 3 code examples, look for 2 things: how we're watching for data, and the callback, which is what to do when you have observed that data has changed. So in our app, we're using the observable pattern. Observables are an implementation of data binding. We used to use simple callbacks before observables were adopted by common frameworks. We keep a connection open to the database by observing part of it and receive events in a stream. And whenever we receive an event, we do stuff. So this bit of Swift code renders the profile on an iPhone. And here's a visual reference from Hubbub Ducky. So you can see that we're watching the database with .observe, and 2, the callback that gets called when the profile changes. When it gets called, it sets the data on the view, which causes changes on the view to render. So moving on to Android, here's an example using the Firebase Android SDK. So in this case, we're watching for data with add listener for single value event. So as an aside, this listener, which isn't an observable, grabs the first piece of data that comes in through the stream and closes the connection afterward, because we're not expecting profile data to change a lot during this user session. And then the callback, as you can see, sets the profile data. Moving on to web, here we have some TypeScript. Again, making the profile. Our app uses Angular 4, and this code works for Angular 2+. So you can find the place we're watching for data at observable data.subscribe. So observable data has the database reference in it. When you subscribe to the observable by calling .subscribe, that opens up a database connection if there wasn't a connection open already. So the key point here is you can listen to an observable in multiple locations in your code, which is nice because if you've got a bunch of subscriptions to the same piece of data, all of them can use the same single connection to the database. And of course, we've got the callback setting the profile data that we just got. And this lives in an Angular service that lives somewhere else. Of course, we have situations where the client needs to talk to the server, too. So now let's talk about data flowing both ways. One reason data binding is convenient for developers is that you can use the same code to do the initial display of data to the user, as well as render dynamic data that comes in during the user's session. So to illustrate, let's look at how the user selects events to join. On the admin console on the right, a web app, we've defined some events and sent them to the database. The client on the left gets this data from the database. The person uses the app to select some events, and the client sends back, hey, I'd like to sign up for lunch on Friday. So this is where observables are really handy. So here we have some more client code. Here's how we present the view of events with checkboxes in the web app. So hearkening back to what Sarah said earlier about organizing your models, we keep the list of possible events separate from the ones that the user has signed up for. So they're in different parts of the database. And as Sarah mentioned, we're using security rules that are easy to reason about and express. So the list of possible events is writable only by admins, and the user's event signups are only writable by that particular user. So when it comes time to combine this data, we're doing it on the client. So the interesting thing to look at in this bit of code is how we are chaining observables. So we've got full slot list watching the list of possible events, and user slot list watching this particular person's signups. So for events, for like which events to display, we're using real time for configuration. So just for a little note about configuration, there's many ways to do this. In our app, we use like 3 ways of configuring things. So first, we've got live configuration, which is how we configure the kill switch for the iOS app to tell you to upgrade. And we've got app build config, which is like staging and production URLs, tokens, secrets, and of course, the real-time database to tell us what events we're showing. So we used real-time for configuring events because we wanted to be able to create events live and assign groups dynamically. So with the real-time database, user state syncs across web and mobile, staying visible and up-to-date on each. So we can also imagine a multi-party interaction. Maybe there are many people looking at their pending events, and at that moment, an admin, one of us, assigns groups. This triggers a cloud function, writes new data back to the real-time database, and users will see their event get updated in real time. So, who wants to see this magic happen? Let's have lunch tomorrow. So go to hubbub.live and download the app. Sign yourself up for the time slot for tomorrow. And at noon, we're going to meet at the gray Android, which is near this stage, on the lawn. This is what it looks like. And we'll hold up our phones and find each other. So apologies to the live stream audience. We've built a hyperlocal real-time app. So many, many thanks to our fellow hubbubs who worked on all of this. Please stand up and give us a hubbub wave. And thank you all for coming. Come hang out with us at the Firebase Sandbox, which is in that direction. All the hubbubs and the Firebase team will be available to answer questions. Thank you.
Thank you.